Here's another example, example 3. It says, in the triangle shown, solve for the unknown side and angles, round your answers to the nearest tenth. Okay, so again, we have two sides and one angle. All right, and one of the sides is across from the angle, and one of the sides is on the side that's forming the angle. Okay, so we're gonna start the same way that we started before. So since we have this side and this angle, by the way, AB, so this is gamma, this is angle gamma, and this is side C, and this side is side B. So what are the three that we know are gamma C and B. So the fourth element is going to be angle beta that we're going to involve in our solution right now. So, okay, we're going to have sine beta over B is the same as sine gamma over C. So from here, what is the unknown? Unknown is beta. So sine beta equals B times sine gamma divided by C. And when we plug in the numbers, we're going to get 9 times sine of 85 degrees divided by 12. Okay, let's put it into our calculator. So sine beta is approximately 0.747. Now, how do we find beta? Well, beta is the inverse sine of 0.747. Okay, when I put it in my calculator, again, I'm gonna get that sine beta is approximately 48.3 degrees. But just like in the previous problem, let's take a look at what's going on here. So again, on the unit circle, the arc sine gives you the angles in the first and the fourth quadrant. The 48 is going to be here. Okay, so this is our angle. So there is a possibility of another angle with the same sign right here. And so we're going to call this one beta 1. So there is a possibility of beta 2. And the beta 2 is 180 minus 48.3 degrees. So beta 2 is approximately, let's see, 131.7 degrees. Okay, so we have two possibilities for our beta, which will we have to check both. So we're gonna have case 1 and case 2. So case 1, if beta equals actually 48.3 degrees, then what do we have? We have that our alpha is 180 minus 85 and minus 48.3. And that gives us the alpha of 46.7. Okay, so we found our we know our beta now, we found our alpha, we know C and B, we need to find A. So again, I would like to use the values that I was given, meaning C, side C, and gamma. So we have C divided by sine gamma, and I want to find side A. So it's A over sine alpha. So from here, I have A equals C times sine alpha divided by, I'm sorry, this is gamma, sine gamma. Okay, let's put in the numbers. C is 12 sine alpha, which is 46.7 divided by sine of 85 degrees. And when we put this into the calculator, we're gonna get approximately 8.8. Okay, so case one. Let's list all of the angles. So we have gamma is 85 degrees, beta is 48.3 degrees, and then angle alpha is 46.7 degrees. We have side C is 12, side B is 9, and side C is 8.8. So that's our first triangle. That's for case one. Let's take a look at case two. And so case two is if beta is 131.7 degrees. Okay, then what's our alpha? Then alpha is 180 minus 85, right? Angle gamma, and minus angle beta, which is 131.7 degrees. But look, when we put this in the calculator, we get a negative 36.7 degrees. So in this case, angle beta is too large to accommodate 85 degrees and still, you know, for the sum of all angles being equal to 180. This is just not possible. So in this case, there is no case two. Okay, so this is an impossible case, right? So this is not possible. So in this case, we have only one triangle, but always check to see if there is actually a possibility of a second triangle. And our last example in this video is example 4. Find all possible triangles if one side has a length of 4, opposite angle of 50, and second side has a length of 10. So let's sketch the triangle, see what it could have been. Okay, so let's see. This is a 50-degree angle, right? And the side opposite of that angle is 4 units. And the second side has a length of 10. So it doesn't matter which one. Let's call it this one. Let's call this angle alpha. and that's going to be side A. And let's call this angle beta. So this side is B. And we have angle gamma, and this side is C. So using, again, we're gonna apply our law of sines, and we're gonna we need to use at least all three basically values that we know: the angle, the side opposite of it, and the side. Okay, and so we're gonna use the angle across from the known side. So we're gonna have sine alpha over A equals sine beta over B. And we're solving for beta. So sine beta is B times sine alpha over A. So what do we have? We have 10 sine of 50 degrees divided by A, which is 4. All right, and when we put this whole thing into a calculator, we get approximately 1.915. But sine, so what do we have? We have sine beta equals 1.9, almost 2. And we know that this value is outside of the range of sine. So the range of the sine is between -1 and 1. It cannot be 1.9. So it's an impossible value. So this value is outside the range of sine. What does that mean? That means that no such triangle exists, right? No such triangle exists. Here's the picture that depicts this problem. So we have an angle of 50, the side of 10, and the opposite side of 4. It's just too short. This angle is quite large, 50. The side is short, and this side is long compared to that side. Remember, we said that angles on the opposite sides are proportional. So yeah, this is an impossible triangle. Okay, this is it for an ambiguous case. And in the next video, we're gonna look at our next combination of angles and sides.